Let's talk about Form 2. So if we start with question 1. This one's pretty easy. It's a word scrambler program. And it's only strings with uppercase letters. And we have two methods that are related to one another. And the first one is the one we're going to write in part A. And it just takes a simple string parameter and returns a scrambled version of that string. So let's go through how that works. Scrambled word takes in a given word, returns a string that contains a scrambled version. It begins at the first letter of the word and continues from left to right. It's looking for an A, followed by another letter that's any letter other than A. And if it finds that sequence, then it swaps the two letters. Once we swap the letters, we move on to the next swap, and we don't involve them at all. So how does that look on paper? Or how does that look in code? We look in Form 2. Let's go Part A. So let's take a look at this. Create a string to hold the final scrambled string. We're creating a while loop, and the reason why is because we don't want to move forward unless we're swapping letters. So we actually, it's different in under. So if we're going to swap letters, we're actually moving forward too. Remember the rule that it said that if we swap two letters, neither letter can be involved in a future swap. Okay? However, if we have a letter that is swapping, we move forward two, right? But if we didn't swap the letters, we only want to move forward one because we know the first letter is not an A, right? So we know that it can't be an A followed by not an A. We know that's not the sequence. We know we're not swapping those. So we move on to the next one and check it with another one to see if we can swap that. Okay? So we only move forward one. We only skip one of the letters if we don't find a swappable match. If we do find a swappable match, we're skipping both of the letters on the next run. So we have the next letter to check, which is at position I through I plus 1. So it's just a simple substring. We've done that before. Letter 2, we're going to set to an empty string. The reason why, we need to check if there's a next letter, right? Because if there's not a next letter and we call I plus 1 and I plus 2, what's going to happen?
Index out of bounds.
Index out of bounds exception, right? If you don't have this in your final answer, I'm not going to take points off, I don't think. But try to remember that that's the case. So now this is the tricky part. There's a series of if statements that you could do to make this a little bit more complicated, right? But if you do this, as long as a letter is not equal to an empty string, and letter 1 is an A, and letter 2 is a not A, then we swap the two, and then we move up 2 to skip both of those letters. Questions on that part? If you had Form 2, look at that very carefully and make sure that you don't have a question on that part because that's a little tricky. If not, we're just adding letter 1 to the scrambled version, right? So we're just adding it, and hopefully some of the other letters will be scrambleable. Okay? Scrambleable. It's a word, I promise. Then we just skip that letter, right? We add letter 1 to scrambled, and then we skip that letter. And we start again. We see if there's something else to be swapped. Eventually, hopefully, we'll run into an A and be able to swap some stuff. Questions on that right now? Okay. Let's tackle part B. Now we're going to scramble or remove. So basically what it's asking you to do here is we're going to replace each word in our word list with its scrambled version. However, if the word cannot be scrambled, meaning there's no A's in it, we're going to remove that word from the list. Okay? So that I feel like that's kind of simpler than than part A for a lot of reasons, but we'll go through it. So let's check this out. Part B. We're going to use a while loop because, again, remember what I said before about removing stuff from an array list. If I know I'm removing stuff from an array list, scramble or remove, it says it in the title, I know that I'm probably going to use a while loop here because I'm only going to iterate forward under certain conditions, right? If I'm removing a word, I probably don't want to iterate forward because then I would skip. So call my iterator I, as long as that's less than the size of the word list. That means I will not get an index out of bounds exception, and we will be okay. We're going to set our word equal to the current index or word list at the current index, which is I. And we're going to take that and we're going to put it through the method that we wrote in part A. We're going to scramble the word, right? If we were able to scramble it, that means it will not be, that means the scrambled version will not be equal to the original word. If that's the case, if we have a new word, then we just set the new value at position I equal to the scrambled version. And then we move on to the next word, I plus 1. Again, if we're removing, we're not doing I plus 1 because it does it automatically when it shifts everything to the left. Now, word list.set is something that you should know because you've worked with a lot of array lists. But if you do not, again, you look at the bottom, you have an appendix that has that information for you. Questions on that part? Question 1, to me, it's pretty good. I don't think most of you guys should have a problem with that. So let's try. This hierarchy should be pretty simple for you guys. There's no interfaces or anything. There's an abstract class pet. You're not going to go into a pet store and say, hey, I'd like pet. You're going to say, give me dog, cat, guinea pig, bearded dragon, that kind of thing. So we'll make they give us the class pet, right? And they give us a subclass dog that extends pet. The implementations of these things are not known, but we know that they return a string, right? So it's going to say something like woof, right? Because that's how dogs speak. So given the class hierarchy shown above, write a complete class declaration of the class cat, including implementations of its constructor methods. Remember that the speak return is meow. So really super simple class to write. I don't know if I even wrote any notes on this one. Yes. It extends pet. We have a constructor that has the name of the cat. We pass that to the super because why? Why do we need to pass that to the super? Private variables. We are going to be giving the super data, and we do not have a default constructor, which means this is 100% absolutely necessary. And string speak, just returns meow. It told us to return meow. We're going to return meow. Anybody have questions there? I must be explaining things super good because yeah, it's big baller because nobody asks questions. All right, so let's write a new class, huh? Part B. Soon the class dog has been declared as showed at the beginning of the question. We saw that class. If the string dog sound is returned by the dog method speak, then loud dog method speaks returns string containing dog sound repeated 2 times. Given the class hierarchy shown previously, write a complete declaration for the class loud dog. So loud dog is a type of dog. So public class loud dog extends dog, right? Pass the name to the super for the same reasons we explained before. String s equals super dot speak. That's a little verbose for what we're doing. I would probably say something along the lines of return super dot speak plus super dot speak. I could probably do that as well. Either way, it's good. Questions on that one? Okay, because we just did interfaces and inheritance. This should be fresh in the mind. We should have no problem with this one. That's an easy one. It's an easy payday. Part C. We have a kennel. Kennel's pretty similar. We have an array list of pets. Why do we have an array list of pets? Anybody? We make it pets because pet is the superclass, which means that if we make an array list of pet objects, we can fit cats, dogs, and loud dogs in there. Because it's a kennel, we're going to have a variety of different animals. Right? And then all they want you to do is write the all speak method. We have an array list of pets that contains all our pets, and we basically just want to run the speak method on all of them. So looks kind of like this. Run the all speak method for each pet in our list. We're going to run, we're going to say the name, and then we're going to say what it says. So Max the cat says meow. Fido the dog says woof, etc., etc. If Fido's a loud dog, he will say woof, woof. Questions? Okay. Guess we will move on to question 3. Question 3 is a fuel depot that has a robot that fills the tanks. So we have an array of tanks in an index, and the robot's gonna decide which ones to fill. So we have an interface for the fuel tank, and then we have an interface for the robot. That's having those both be interfaces is a little weird, but we'll get over it. Fuel depot, part A. Going to find the next tank to fill. Okay. Determines and returns the index of the next tank to be filled. We decide on the threshold, and we pull that in as a parameter. Any of the tanks that are determined to be lower than the threshold, we're going to fill, and we're going to fill it at the lowest one of those first. So I sense a big, long if statement coming, right? So let's see what happens. So we set index of the minimum. We set a variable for the index of the minimum, the lowest, the tank with the lowest fuel level, right? And to start off with, we're going to set that equal to the tank where the robot currently is. So filler is our robot, getting current index. We're getting the index where the robot currently is. Then we're going to loop through the rest of the tanks. Now, we're going to first check if the fuel level is below the threshold, right? That's going to short circuit. If we look at the tank and it's not below the threshold, whole thing's gone. We default to here. We just return the index of the robot, right? If we don't short circuit here, we do find one that's below the threshold, all we have to do is initially check to make sure that it's less than the level where the robot is, and then we can keep looping through until we find the lowest possible fuel level. Either way, no matter what the outcome is this, as long as we don't get a short circuit here, we want to set the minimum index or the lowest fuel level to position I. Then we're just returning that position. So we're returning, essentially this works out, we're returning the position of the next tank that needs to be filled. Questions on that one? That one's really, there's not a lot of code there, but that's a pretty complicated answer. I hope that if you have questions, you make the time to come talk to me and ask. Part B. This one's a fun one. So, we're moving the robot to the location of the next tank to be filled. Okay? So, loc index is basically what we're pulling in as a parameter, which is the location of the current tank that needs to be filled. So loc index is the index of the current tank that needs to be filled. Now we have to find the index of our robot. So filler is our robot, and we're getting his current index. If the tank to be filled is to the right of our robot, that would mean that our index of the tank to be filled is greater than the index of our robot. If that is the case, we need to check to see if the robot is facing right or left. If you look, we have a method for that, right? If it's facing right, we have to change the direction because, or if it's not facing right, we have to change the direction because our index is to the right. Then we're going to use the move forward button, and we're going to move forward the number of indexes that we need. Questions on that part? We're actually moving the robot loc index minus index number of spaces, which will give us the location of the tank. If the tank is to be filled, the tank to be filled is to the left, that would mean that loc index is less than the index of the robot. Now we have to make sure if the robot's facing left. If the robot's facing right, then we have to change the direction of the robot, then move forward the appropriate number of indexes. What do we do if the robot is already on the lowest? If the robot's already on the tank that needs to be filled, do we need to do any of this? No, so we don't need an else condition here. We don't need to do anything else, right? Questions? Okay, fuel depot's done. Number 4. This one is fun. This is another one of those that seems more complicated than it is. Okay, so we have a telescope that's basically scanning sections of the sky in a grid. They give you the wording in here is a little complicated, but essentially, you guys have probably in science class or some other things. I think middle school science they do this. You observe an area in a grid, right? Telescope records the grid data in the form of one big 1D array, right? And our job is to put it back into a 2D array so that it makes sense. Because the way it records the values is the telescope is moving back and forth through that section of the sky. So if you look here, the way it's reflected in the 2D array is that. Okay, so we have to set up a loop that's going to go forward. So we have, if you look at this, just this image, right? We're moving to the right on row 0, then we're moving to the left on row 1, right again on row 2, left again on row 3. What's the algorithm that we can determine from that? What do we determine is going to happen if we're moving backwards and forwards? Basically, what I would say if the row's even, right? 0, 2, 0 and 2, we're going right. And if the row's odd, we're going left, right? 1 and 3, we're going left. So we've already knocked out an if statement just by looking at this picture. Okay? So our job is to write the entire Skyview class. So we need to write the constructor. What does this constructor do? It creates our double array from the 1D array, right? So it pulls in the parameters, number of rows and number of columns. So number of rows is the number of times that the telescope has switched directions, or the number of scans back and forth that the telescope's made. The number of columns is basically the number of different sections that it's broken those scans up into. And then this is the scan data. This parameter is the scan data in the form of a 1D array. And that is the size is the same as the number of rows. The total number of values contained in our scanned array is the same total number of elements that's in view. So if we're going to do this constructor, it's going to look something like this. So int numRow scan. We're initializing an array with the appropriate number of rows and columns. So we got the rows and columns, right? We just do new double, number of rows, number of columns. That's pretty straightforward. We're going to start at row 0, column 0, and we're going to grab each light value from the scanned array. So for that, we can actually just use an enhanced for loop, which makes things super easy. Just create a double for the amount of light in scan. So for each amount of light in scanned, we're going to add it to the view. We're going to add it to row column We're going to set view at row column equal to the amount light variable. Now our job, once we start at 0, 0, that's the easy part. Our next job is to find the next column to add a value to. And that's a little bit tricky, okay? So we're setting our next column equal to the initial column value, and then we're going to determine if the row is even. If the row is even, right, we're going to move to the right. Because our even, we go right. So next column is 1 higher than the original column, than the previous column value. Otherwise, we're on an odd row and we're going in the reverse directions. So we just subtract 1 from the column value. As long as our column value is between 0 and the maximum column value, then we can move to the next column. Otherwise, we add 1 to the row and start over from 0. Questions on that constructor? Okay. The next one, actually, once you understand that part, is kind of a little bit easier than the constructor. Once we've got that dialed in, this is pretty easy. What it's asking us to do is take a section of our grid, right? So it'll have from row and column to row and column. So from a start point to an end point, check all those values and find the average amount of light in each one. That's why it's called get average, right? So we take in parameters for a start row, an end row, a start column, and an end column, okay? So basically it's start row and column, end row and column are 2 data points, right? So we're checking all the values between those, and we are finding the average. So I'm going to start with a double, and that's going to hold the average at the end. So in the rows we're checking for, this is going to be a double, a 2D for loop, right? So we're going to check all the rows, and that's going to begin at start row and end at end row. Same thing with the columns. We're going to check all the columns in each row. We're going to start at start column and end at end column. That part's super simple. We're going to add the value there to the sum. Once we've calculated the sum, meaning once this for loop is complete, we can take the sum and divide it by the difference between those 2 data points. And you can also write this out in a simple way that's like, you'd have to type a little bit more, but there's obviously a simpler way to do that. Basically, you can just use the total number of spots. So honestly, if I were making this easier on myself, right? This is like probably the most efficient way to do it. But we could also set an integer for num values. And in here, every time I add 1, every time I grab a sum, I can just say num vals plus plus. And then I could just divide this by num vals. It's another kind of easier way to do it. And that does it for Form 2. That might be, yeah, that's going to be all we have time for. Do you guys have questions on this one? Yeah. I'm going to make you videos for Form 3 and 4. Yeah. I'm going to make better ones than these two.
Wow.